All right, we are now in section 6.5, point slope form and writing linear equations. So you're going to now know a third type of form when involving equations. So let's go over what point slope form is. Using point slope form. All right, you do not need to write any of this down, but this is what we're going to go over. We're going to actually review where does point slope form come from. So let's use our definition of slope. So as you know, slope is right here, and that's equal to m. Now let's review point slope. When do you think you would use point slope form? When you're given a point and a slope. So, suppose you know that a line passes through the point 3, 4 and has a slope of 2. Now let me show you that you are not going to go through these steps here. You're going to skip straight ahead and use this form. We're just actually defining and going over where this form comes from. So if I take 3, 4 and substitute them in for my x and y values, and I substitute 2 in for the slope, which is m, and I want to solve, look what I'm going to do here. I'm going to multiply both sides by x minus 3. So multiply both sides by x minus 3. The x minus 3 is over here, divide by itself, so they cancel. You're left with y minus 4 equals 2 times x minus 3. And that's it. This right here is point slope form. This represents your x coordinate of 3, your y coordinate of 4, and your slope of 2. So here's your definition of point slope form. Point slope form of an equation of a non-vertical line that passes through the point xy. You are given a point and a slope. The x value goes here, the y value of your point goes here, and the slope goes in front of the parentheses. So let's go over an example. Now I've actually given you the answer already here, but let's graph using point slope form. Now once again, you could actually distribute the 1/2 and add the 5, put it in slope-intercept form and graph from there. But let's look. Our point, this is our x value, this is our y value. Therefore, 2, 5 is our point. So I can put a point right here at 2, 5 on my graph. My slope is right here. My slope is 1/2. So I go up 1 over 2, up 1 over 2. There's my other point, which is in blue. I draw my line between it. And there's graphing using slope and point, so point slope form. So let's actually do another one together. Y minus 5 equals negative 2/3 times x plus 2. Now my x value is here, but wait a minute. My formula is x minus. So if my formula is x minus, what would you plug in for x to get plus 2? It'd be this. You'd actually plug in a negative 2. So my x value is negative 2. My y value is 5. So that means my point would be negative 2 and positive 5. Now my slope here is negative 2/3. So if my slope is negative 2/3, let's graph this. So we're going to graph negative 2, 5. So if we graph negative 2, 5, the point's going to be about right here. Now our slope is negative 2/3. So we're going to go down 2 to the right 3. So if we draw our line, it crosses through negative 2, 5, and it goes down with a slope of down 2 over 3. All right, now the next examples I want you to pay careful attention to. While these seem easy, students have problems with these. You have to be fluent. If I ask you, write an equation, and if I ask you point slope form, standard form, slope-intercept form, write it from a graph, write it from 2 points. You have to be able to interchange and use all these together. So we're going to start off by writing an equation in point slope form. Now in this problem, I'm given a point and a slope. So my equation is y minus y1 equals m times x minus x sub 1. So the first thing we do is just substitute in. My 7 is going to go right here. My negative 1 for x is going to get plugged in here. And my slope gets plugged in for m. So if I plug that all in, that gives me y minus 7 equals my slope of -3 times x minus -1. Now, that would give me y minus 7 equals -3 times x plus 1. And that's my equation. That's really as easy as it is. But if I said write it in slope-intercept form, you'd have to distribute the -3, move the minus 7 over. If I said standard form, you'd have to move the ax plus by to the left and your constant to the right. Now, m equals 2/5, and my point is 10, -8. Pause the video, do this one yourself. If you did it correctly, you'd have y minus -8, which turns into y plus 8, equals slope 2/5 times x minus 10. And there's my answer. Now, example number 3, using 2 points to write an equation. Now, I want to make note of this. 2 points are either going to be given to you as 2 points, like I'm writing down, or they may give you a graph. Now, here's the trick. They usually do not even give you the points on the graph. You will have to come up with your own points. So that's when you'd actually look at this graph, and you'd be able to say, okay, there's a point at 2, 3, and -1, -5. So use 2 points to write an equation. Now, I want you first to write it in point-slope form. So, you know what? No. Let's write it in slope-intercept form. I want you to write the equation in slope-intercept form. Y equals mx plus b. Now, the first thing I want you to know is this. Just because it says to use point-slope form, just because it says to write it in slope-intercept form doesn't mean you have to use slope-intercept form. You can use point-slope form. So I'm going to show you both ways. So we're going to use point-slope form. Here's why. Ladies and gentlemen, slope-intercept means I'd have to have slope and y-intercept. I have neither one of those. Point-slope form, you need a point and slope. I already have a point, so let's find the slope. Step 1, find slope. I subtract my y's. -5 minus 3. I subtract my x's. That gives me the slope -8 over -3, which means my slope is 8/3. I then pick a point. I don't care which one you pick. I'm going to pick 2, 3. It looks easier. So y minus 3 equals my slope, which is 8/3, times x minus 2. Now, if I asked for point-slope form, you would be done. But I'm now going to distribute. That gives me y minus 3 equals 8/3 x minus 16/3. Or you could write it as 5 1/3. I then add 3 to both sides. That gives me y equals 8/3 x. Well, this would be 5 1/3. So I have -5 1/3 plus 3. That would give me -2 1/3. So my answer will be y equals 8/3 x minus 2 1/3. Let's say you had chosen to use -1, -5. If you took that and plugged that in, you would end up with the same answer. Let's say, though, that instead of using point-slope form, you used y equals mx plus b. So let's say, I'm going to do it a completely different way. You still would have found 8/3 as your slope. I now use y equals mx plus b. I want to find b. So right now I'm going to plug in my m, my x, and my y. So my slope was 8/3. I plugged that in for my slope. My x is 2 from the point up here. And then I get 3. So that gives me 3 equals 16/3 plus b. I subtract 16/3 on both sides. That's the same as taking 3 minus 5 1/3, which would give you -2 1/3. You could take the slope and the y-intercept, plug them in, and you would get the same answer. The next thing we're going to do is actually use data. Use data from tables, t-tables, to write an equation. All right, example 4. Is the relationship shown by the data linear? If so, model the data with an equation. Now let's remember that something that's linear means it increases by the same amount on both y and x. So you could say as y increases by this, x increases by this. This does take a little bit of work, I'm not going to lie. So what happens to y here? It goes up by 2. What happens from y here? 6 to 7, it goes up by 1. 7 to 10 goes up by 3. You cannot just look at that and go, nope, not the same amount, not linear. We now look at the x side. Negative 1 to 3 is plus 4. 3 to 5 is plus 2. And 5 to 11 is plus 6. We have to find the slope. Change in y over change in x. It's something you will use so many times. So between these 2 points, we're going to find the slope from these 2 points, this point to this point, the slope from this point to this point, and then this point to this point. So change in y over change in x. Change in y over change in x. Change in y over change in x. That's slope. This gives you 1/2. This gives you 1/2. This gives you 1/2. This is linear. So is the relationship linear? Yes. It's linear. Now we need to write an equation. Now it doesn't say what kind of equation to write, so we can write it in slope-intercept. We can write it in point-slope. So we already know the slope. Here's what I would look at. I have a slope. I have a point. I would use point-slope form. Pick any point you want. It doesn't matter. I'm going to say, oh, this one looks fun. 3, 6. So that would give me y minus 6 equals 1/2 is my slope, x minus 3. That would be my answer. My favorite is I always like to go one step further, and I do always like writing it in slope-intercept form. So you could do that. So you could take y minus 6, okay, distribute the 1/2, and then I add the 6. So that gives us 1/2 x. 6 minus 1.5 would be y equals 1.5 x plus 4.5. You could have plugged in any one of these points and you would have gotten the same answer. I would accept either one of these as a correct answer. Our last example. Is the relationship shown by the data linear? If so, write an equation. I've already done all the work here. We have boiling point of water, altitude is your x, temperature is your f. So looking at this, let's go over and divide each of these. You could do change in y divided by change in x, change in y divided by change in x, change in y divided by change in x. If you simplified all of them, they would all give you negative 1.8. So therefore, yes, it's linear. And your equation would be, let's use point slope. Y minus, pick any one of your points. I'm going to pick this one right here. Y minus 206.6 equals my slope, negative 1.8 times x minus 3. And that would be an equation that models the data. Now, this is a great review. Page 339. I would suggest you mark this in your book somehow, but make sure you know slope-intercept form, standard form, point slope form, and how it looks.